All right, section 8.3, trigonometric integrals. There are several techniques for this. It depends on the powers of the sine and the cosine we're going to work with first. So if we're looking at the integral, and this is part A, cosine to the fifth of x dx. Okay, when it's odd, the easiest thing to do is to make it even and pull off one of the cosines. And so then we're going to use the identity. It's the Pythagorean identity. Cosine squared of x plus sine squared of x, or theta, oh, I changed my mind, equals 1. And I'm going to solve it for cosine squared. So the cosine of the fourth will turn into 1 minus sine squared of x squared. And then we're going to make a u substitution and let it be the sine of x. And so du is going to be the cosine of x dx. So this right here is your du, and your sine is your u. So this turns into 1 minus u squared, quantity squared, du. If I square that out, I get 1 minus 2u squared plus u to the fourth. And then if I integrate that, I get u minus, raise the power, flip it in front, raise the power, flip it in front, plus a c, but I've got to turn it back into sines. So it turns out to be sine of x minus 2/3 sine cubed of x plus 1/5 sine to the fifth of x plus c. With even powers, it's a little bit different. With even powers, you have to use the half-angle formulas. And we use a different version of them than you usually use in trig. I think I've said this before. We use sine squared of x turns into 1 minus cosine of 2x over 2. And cosine squared of x turns into 1 plus cosine of 2x over 2. So for part B, the question was, integrate the sine to the fourth of x dx. So we take it and make it a sine squared squared. So it turns into 1 minus cosine of 2x over 2, quantity squared, dx. I'm supposed to square that out, so what I'm going to do, and I'm going to make two steps out of this. That 2 on the bottom is going to be a 1/4 outside. And then we're going to square that piece. So 1/4 the integral of 1 minus 2 cosine of 2x plus the cosine squared of, of 2x dx. Oh, but now we have to do it again for this one. So now we get 1/4 the integral of 1 minus 2 cosine of 2x, and then cosine squared of 2x turns into 1 plus twice the angle, so 4x over 2 dx. And if I pull stuff apart, to put that 1/2 in top and bottom of that last piece and collect my like terms, I have a half plus the one that's in the very front, so 3/2, minus 2 cosine of 2x, and then plus 1/2. Oh, I left a cosine out right here. Nice. It's cosine of 4x. So 1/2 cosine of 4x. Sorry about that. This piece right here should say 1 plus cosine 4x over 2. Now I'm ready to integrate. So the 1/4 is just going to hang out. Integrating 3/2, you get 3/2 x. Then we get minus, okay, integrating the cosine is going to be the sine, but it's going to be 2 times the 1/2, because you have to take the derivative of it. So I need a 1/2 in front. It's going to be 2 over 2, so that's going to go away. And then here, the integral of cosine, again, is the sine. But I have to put a 1/4 in front to counteract the derivative, which is 4. So that makes that a 1/8. And so if I distribute the 4 back out, which is what the book did, it seems kind of strange. It seems like it'd be easier to factor things out, but okay. You get 3/8x minus 1/4 sine of 2x plus I'm missing something. What am I missing? No, I'm not. 1 over 32 sine of 4x, and then plus your c. If I were simplifying this, I might be inclined to write it like this. This looks a little neater to me. Whoops, that was not right. Try that again. I would take out the common denominator, and then I would get a 12x here, because 12 over 32 would reduce to 3 over 8. And then the next one, I'd pull out the 1 over 32, so I'm going to need an 8. And the next one is just a sine of 4x plus some constant. They are exactly the same answer.